What if time isn't a straight line, but something we can bend, twist, or even loop? What if our universe already holds the keys to time travel, hidden in the very equations that describe it? It sounds like science fiction, yet modern physics whispers that it might not be impossible at all. To understand how, we need to follow the story of time itself, from Einstein's relativity to quantum theory and the strange world of paradoxes. Einstein changed how we think about time forever. Before him, time was absolute, the same for everyone, everywhere. But relativity shattered that illusion. It told us that time and space are woven together into a single fabric, space-time, and that fabric can stretch, twist, and warp. When you move close to the speed of light, time for you slows down compared to someone standing still. That's not speculation. It's been proven with atomic clocks on fast-moving jets and satellites. Travel fast enough or live near a massive object like a black hole, and you'll experience time at a slower rate. You could leave Earth, travel near light speed, and return to find that decades have passed, while for you only a few years went by. That's not fantasy. That's special and general relativity, and it means time travel to the future is already part of nature's design. But what about the past? That's where things start to bend both our logic and our imagination. Einstein's equations don't forbid moving backward in time. In fact, they allow something called closed time-like curves, pass through space-time, that loop back to their own starting point. In 1949, the logician Kurt Gödel found a solution to Einstein's field equations, describing a rotating universe. In that universe, by following a certain path, you could return to an earlier point in your own timeline, a literal mathematical time loop. Other physicists have explored similar ideas. Wormholes, for example, tunnels through space-time that might connect distant points or even different times. If such a tunnel could exist and remain stable, it might let us step across centuries in a single moment. But here's the catch. Once you can travel backward, paradoxes emerge. Could you prevent your own birth? Could you destroy the cause of your own existence? That's the famous grandfather paradox, a question that physics can describe, but not easily answer. Quantum theory, however, plays by different rules. In the quantum world, particles can exist in many states at once, and reality seems to branch at every decision. That leads to the many worlds interpretation, the idea that every possible outcome of an event happens, each in its own separate universe. From this view, time travel doesn't rewrite history. It creates a new one. Go back and change something, and you simply jump to a parallel timeline where your new action becomes the new history. Your original universe still exists, untouched. So paradoxes dissolve, but they leave behind an even stranger idea, that there may be infinite versions of reality, each born from a single quantum choice. And beyond equations lies philosophy, the question of what time really is. Is time a river flowing forward, carrying us from birth to death? Or is it a vast landscape where past, present, and future all exist together, and our consciousness simply moves through it, frame by frame? If every moment already exists, then traveling through time might just mean shifting our awareness, not changing reality, but choosing which slice of it to experience. Yet the paradoxes remind us that nature guards its secrets carefully. The bootstrap paradox, for instance, imagines information or an object that loops endlessly through time with no clear origin. A book you write because you found it in the future. Who wrote it first? No one. Or perhaps everyone. So, can we truly travel through time? To the future, yes. Physics allows it. To the past, maybe, if the universe's geometry permits it. But perhaps the deeper truth is that time travel isn't about machines or wormholes. It's about understanding the strange relationship between cause and effect, between what was, what is, and what might be. Maybe the universe already contains every version of time, and we're simply moving through it, one conscious moment at a time.